Hello everyone, my name is Mia. I'm a third year student at UBC and I'm in combined honors of biology and computer science. So I found math to be pretty interesting, so I hope you could also enjoy this math video in the following minutes. Let's get right started. The topic today is quadratic equations, number 2. So I believe we already have some idea about it. So this is our learning outcomes, which means we are expected or you are expected to know all of this at the end of this course, at the end of this video. But don't be overwhelmed by all of this. Let's step through this and you will find they are not really intimidating. If you like to have a definition of it, it is any expression in this form, plus bx plus c equals 0, in which a, b, c are all constants, which means they will not change like x do. So, for example, ABC could be anything like 2.4, 700, log of 4, or minus 2, any constant, any number. But in the specific case of the quadratic equation, a cannot be 0 because, well, let's think. If a equals 0, we will completely miss this term, this x squared term. So it will become a linear function here, like 5x plus 12. So in this table, we have some examples of quadratic expressions. On the left, you can see basically any expression contains x squared. And x squared is well, the highest power of x is x squared, and that is a quadratic expression. And on the right, we have all kinds of functions which are not quadratic expressions, sorry. So linear, and this is cube, we will call it polynomial. And this is logarithm and a tangent function. They are not quadratic expression. Okay, so now let's look at the actual graph of a quadratic equation, which is on the right, this orange curve. This shape of a quadratic equation is called parabola, which can open either upwards, like in the shape of U, or open downwards, like this. It depends on the sign of the A here, but we will discuss this a bit later. So given this equation, we can actually create a table of values. And let's complete this table and see if we can find any pattern of this quadratic expression. Okay, now, so I have completed the table. And what we can find is that the value of y seems to be symmetric around when x equals 1. The value of y on both sides is -3 and 0. So if we also compute x equals -2, we will find the value of it should be 5. So this is actually a pattern of quadratic equation. Every parabola has an axis of symmetry. In this example, the axis of symmetry is x equals to 1. And any x on its left or right side, as long as they have the same distance to the axis of symmetry, they should have the same y value. And now we can look at how we express them algebraically. There are three forms of quadratic equation. The first one, standard form. This one is most useful when we want to use the formula. So if we want to use a formula that we'll introduce later, we have to use this one. The second one, the factor form. We have two constants here, and these two constants, R1 and R2, are the roots, or we call it solutions of this quadratic equation. So the factored form is most useful if we are given the roots, or you want to find the roots and you found this is easy to write it in the factored form. So you can choose this. Okay, so this is R1 and R2 in this graph. That is when y equals 0, or when the graph of this quadratic equation, this parabola, intersects with x-axis. Okay, the third one, the vertex form. As its name, it showed the vertex of it. What is the vertex? Vertex is this point, the point on this parabola, which is also on its axis of symmetry. So it's either its minimum point, as in this graph, or the maximum point if it opens downward. If we have the vertex form of this quadratic equation, we can directly say that the vertex is h, k. And also the axis of symmetry is x equals to h. This one is mostly useful if we want to consider like translation or transformation. Again, we will introduce this a bit later. So these are some useful terms we use to describe a quadratic equation, and we have discussed about them a bit earlier. So parabola, that's the shape, this U shape or downward U shape. The root, which is also the same as x-intercept, it is here. When the parabola intersects with x-axis, we call it its root. So when y equals 0. Y-intercept. Y-intercept, similarly, that is the parabola when it intersects with y-axis. And the axis of symmetry is the value of x if we want to divide the parabola into two equal but like flipped sides. The axis of symmetry is x equals to h. And lastly, the vertex. The vertex is either the minimum or maximum point. So the vertex is, h, k. I think this is enough introduction for this equation. And now let's see how we can really solve it and to find the root of it. So let's start with the simplest way or simplest case. When we saw there is a perfect square of it. This is a definition of perfect square, but basically a perfect square is numbers like 1, 4, 9, 16, 25, and blah 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 blah. They are the square of an integer, or you can say that if we take a square root of them, they produce an integer. Therefore, we call them a perfect square. So if we found there is a perfect square in this quadratic equation, we will cheer because it will be super easy for us to find the value of x. Like in this example here, x squared equals 25. We could square both sides. So if we take a square root of x squared, it is actually the absolute value of x equals to the square root of 25, which is 5. Therefore, x can equals to positive or negative 5. So here we got the solution. Similarly, at this case, we can divide it into cases. So case 1, case 2. Case 1 is that take the square root of both sides. We say x plus 1, plus 3 equals positive 1. And in case 2, we say that x plus 3 equals negative 1. Okay, so in this case, we could move the plus 3 into the right hand side, and we got x could equals to negative 2, or x equals to negative 1 minus 3, which is negative 4. So here we have two solutions, and that is the two intercepts of the parabola with the x-axis. What if there isn't a perfect square? What could we do? One thing we can do is that we can complete it. So as a reminder, here is a formula on how do we expand the square of x plus b. And we could somehow apply it to this equation on the left-hand side. Okay, so let's try to match those two equations. The first thing I think is I don't like this 2 in front of this x squared. So we could divide this both sides by 2, and we got x squared minus 10 divided by 2, 5x plus 6 equals 0. This looks a little bit better because now we have x squared and a squared. They look pretty similar, so we can say in this equation, x is corresponding to a. And that means in this middle term here, minus 5x is corresponding to this 2ab. Therefore, this minus 5x corresponds to 2b, and that makes a 2ab in the middle term. We also need a b squared. So if we have 2b equals to negative 5, b would equals to negative 2.5, right? And in order to complete it, we also need b squared, and b squared equals to 6.25, I believe. Okay, now let's rearrange this to make it a bit clearer. We have x squared, and we have 2ab, 2 times a is x, and we times b is negative 2.5, and we also want a b squared of it, and plus 6. Since I add an extra 2.5 square on the left hand side, we also want it to be on the right hand side. By adding on both sides, I try to complete the square without changing the actual value of this equation. This part of this equation is the expanded form of this a plus b squared. So we have a, which is x. We have plus b is negative 2.5 squared. We move this plus 6 to the right hand side and do the calculation, which is 0.25. Now we have this. This is again similar to the equation when we solved using perfect square. So x minus 2.5 could equals to either positive or negative 0.5. And so we can have x1 equals to 2.5 plus 0.5, which is 3, or we can have x2 equals to 2.5 minus 0.2, which is, I'm running out of space, which is 2. We can verify this in this graphing calculator, which is really useful. So we found, oh yes, these two intercepts are 2 and 3, and which is the same as our final result. Feel free to pause the video and try to solve this using completion of square. Okay, so let's get back together and try to solve it. Again, there is a coefficient in front of x squared and I don't like it, so I will divide or I will multiply negative 1 on both sides just to erase this coefficient. So I have x squared plus 9x minus 1 equals 0. We compare with this form. I found, okay, 9 here is corresponding to 2b. Therefore, b has the value of 4.5. Oh wait, I just saw I made a mistake here. It shouldn't be x squared, this is b squared. Okay, so we have b equals 2.5 and we're missing the term of b squared. So we can add b squared on both sides. So plus 2.5 squared on both sides. Plus 2 times 2.5x plus 2.5 squared minus 1 equals to 2.5 squared. And now, this part of it is the the expansion of this completed square. So that is x plus b, which is 2.5 squared, minus 1 equals to 2.5 squared. And so x plus 4.5 squared equals to 21.25. So x plus 4.5 can equals to positive 21.25 or x or equals to this negative 21.25. Oh wait, square root of it. Oh no, sadly, we don't have an integer here. So this is approximately 0.11 and this is approximately negative 9.11. So there is another way that you can do to solve an equation, which is by factorization. So, the first thing I think I could factor out this 2 out here because either 2, 10, and 12 are divisible by 2, so I could make it simpler by divide both sides by 2. And we got this. And now, this is the most intuitive, or which is also the most complex step in this factorization, is you want to decide how to divide this up. Like, you may think about, okay, 6 equals to 2 times 3, and 2 plus 3 is just 5. But this is -5, so we could make it -2 times -3, which is also 6. And we do this cross product. So x minus 3 times x minus 2, which is exactly the same as this original quadratic equation. I figure this step is a little bit magic, but remember how we expand this multiplication of two terms? We will do x times x times -2, -3 times x, -3 times -2. And this factorization is just a reversion of this step. But yeah, you do have to have some practice and some intuition to figure it out what should be the factor here that could make by adding them you will get this middle term of this -5. So now we have finished this factorization, and if this multiplication of two terms equals to 0, that means either x minus 3 or x minus 2 equals to 0. So we say that x equals 3 or x2 equals to 2. These are the two solutions of this quadratic equation. Let's do another practice. Here, you will find out that in this case, we are missing this constant c. We don't have the constant c in this equation. So this is the case when factorization is the most useful. You can either factor out 2x, so that will give you 3x minus 50 equals 0. Or if you don't want to consider about that too, you could also just factor out x, which is that will give you 6x minus 100. They are exactly the same thing, just whether you like to do one more step or you want to combine them. Again, this is a multiplication of two terms. So if 2x equals to 0, we'll have x1 equals 0. Or it could also be the case that 3x minus 50 equals to 0. If this equals to 0, then x would be 50 over 3. Here we got our two solution or two roots of this quadratic equation. We can do two more practice. Pause the video and proceed when you have done. Factoring it, 3 can only be factored by 1 and 3. Since this is negative, so we either have -1 times 3 or -3 times 1. It depends how we want to add up into this 2. So let's think. If that's 1 minus -1 plus 3, that will give us 2. Yeah, that's what we want. If that is +1 and -3, that is -2. This is not what we want. Therefore, we will factor this -3 into -1 and +3. We don't have other choice for x squared, so that is x times x. We do this cross product thing. So we got x plus 3 times x minus 1 equals to 0. You could re-expand it to check if you have made this right factorization. So either this left-hand side is equals to 0, that will make x equals to -3, or we could have x equals to 1. which will also make this entire thing to be equals to 0. Okay, there is a coefficient in front of x squared. I don't like it. I divided both sides by 2. That will create a problem that we have a middle thing here, which is not an integer. In this case, we may not want to do factorization. I mean, you could still do and create 2 to be the product of two fractions, but it does not really help. Sorry for trick you on that. So we could solve it using this formula, this magic formula. So in order to use this formula, you need to write this quadratic equation into this form, the standard form, and you just have to find out what is the value of A, B, and C, and you can substitute the value into here, and you will get the answer by calculating this entire formula. Why is that this is a magic formula? Is that it can solve all the quadratic equations. You may find it's complex to use completion of squares, or you don't know how to factor it. You can use this quadratic formula to solve it. Let's try to do this question using this formula. So A is 2, B is 9, and C is 4. And we substitute them into it. So x equals to negative 9 plus or minus the square root of 9 squared minus 4 times 2 times 4 over 2a, that is 2 times 2. And you apply everything into the calculator. And you find x equals to 0.5 or negative 4. Oh, sorry, negative 0.5. Pause the video and try to do it. Okay, let's see the answers. So the first one, we can obviously see the value of A, B, and C. We don't have a C here, so C equals to 0. And I skipped the intermediate step because I believe it should be fine by just substitute all those values into this formula, and we will get two roots or two solutions, 0 or negative 1.5. The second question seems to be a little bit strange because we have two roots of the same value, but if you think about it, it should be fine because yeah, we could just have one intercept at here, that is negative 1, 0. Yeah, this could be the case. Okay, the third question. It's not in the standard form, so we move the 2 on the left hand side. So it's in standard form, and we find the value of A, B, C. Everything seems fine. But then we proceed into the calculation, and we found there is a negative number under the square root. No, did I make a mistake? Actually, no. That is what I want you to figure out by yourself. Something we really need to do is to check the value under this square root, which is called discriminant. Discriminant, it will tell us the signs of discriminant will tell us whether this quadratic equation have no roots, or one roots or two roots. So this is this three questions we just did just now. So the third one, so if we look at this graph, yeah, there is no x-intercept, so there is no root, which makes sense. And since this discriminant, the value under square root, is smaller than 0, we can now do this calculation. So yeah, no roots, okay. And the second question, we found that the discriminant equals to 0. So if we look at this formula, this part is 0. So the only difference between the two solutions of x plus or minus 0, it makes no differences. So at the second question, we have two roots of equal value, or just say we have one root. So the graph only intersects x-axis at this point, which is our solution. And lastly, when the discriminant is greater than 0, we have two roots and two intercepts in the graph, and all good. So this is something you really want to do before you apply everything into this formula. It will save you some time if you find, oh my god, the discriminant is smaller than 0. You don't need to proceed anymore, and you can just say, oh, there is no root. Okay, so far so good. Now we want to think about something. If we're given the root, how do we write a quadratic equation for it? Let's say we have this graph here. We're given this graph and we want to write an equation to represent this graph. This is the form of that factored form of quadratic equation being useful here. So remember that the R1 and R2 here represents the two roots of the quadratic equation. So R1 equals to negative 0.5, R2 equals to 2. So we can write this as y equals to x minus x1 is negative 0.5 times x minus 2. Okay, so we have x plus 0.5 times x minus 2. I hope this part is fairly simple and straightforward. Let's move to the next topic, which is the translations of graphs. Translation of graphs is how we add or minus some constant to this equation to move this graph up or down, left or right, without changing its shape. This one, you will find this is most useful if you use this vertex form, because typically when you translate or move this graph, you are moving the vertex of it. Okay, so let's use this graphing calculator to show the translations. Firstly, what is the first one? I guess the horizontal translation. Horizontal translation is changing the value of x. So we minus, say if we minus 2 to x, we actually move it 2 units to the right. How about we plus 2 to x? We move it from this original function, the purple one, we translated it 2 units to the left if we do x plus 2. Vertical translation is fairly more straightforward. You plus 2, you move the graph 2 units upward. You minus 2, you move it downwards by 2 units. When I was in high school, my teacher loved to say that, so left plus right minus. I don't know if that is helpful, but that is how I remember this. So we could also manipulate the graph by transform it. We just said translation does not change the shape of the graph. Now transformation change its shape. First of all, there is reflection in x-axis. The purple one, our original function. If we do like x equals to x squared minus x squared, see it is reflected in the x-axis in comparison to the original function. And this is not good example for the reflection in y-axis, since this is symmetric around this y-axis. Let's have perhaps x minus 2 as an example. So if we want to reflect it in y-axis, we will just add a minus in front of x. Because let's say, for example, x equals to 1 and x equals to negative 1. They are symmetric in the y-axis. So if we just multiply the x by negative 1, we will just reflect this entire graph in y-axis. You can see that they're completely symmetric. The vertex of the original black function is 2, 0, and the reflected is negative 2, 0. We can also do transformation in terms of vertical stretch. So multiply it by 2. See, the new transformed right graph is thinner, and well, we cannot say it is taller because it is infinitely tall, but this is thinner than the original black function because we multiply the entire equation by 2. So for the same x value, it will have a larger y value, which is 2 times the original y value. Similarly, if we multiply this original equation by a number smaller than 1, that is a vertical compress or vertical shrink. The blue graph is wider than the black original function here because I multiply it by 0.5. Similarly, horizontal stretch, we change the value of x, multiply it by 2. You see, it becomes thinner, but at the same time, the position, the coordinates of its vertex has changed from 2, 0 into 1, 0. So this is something you want to pay attention to when you try to graph the transformed function. It does change the position of the vertex. If we multiply x by 0.5, it becomes wider, and the vertex also changed from 2, 0 into 4, 0. I hope that gives you a sense in terms of this transformation. So, in summary, the reflection in y-axis is when we multiply a negative number of the entire thing. Vertical stretch, a larger A will make it taller or thinner. A smaller A will make it wider. And the horizontal stretch, similarly, taller A means thinner, but also this change the vertex coordinates. Next topic, it has been a long video, I guess, is the simultaneous equation. This is not a new thing. Since you know how to solve the quadratic equation, you should also know this. Because if we want to find the intersection of the linear and a quadratic equation, what we want to do is just to make an equation to make them equal, say. Like in this case, that is x squared equals to x. How to solve it? Move it to the same side, equals to 0. This is the standard form. Now, you can use either method you like to solve it. You could complete the square if you like, or you can factor it, or you can use the formula. In this case, I feel like factorization will make it most easy. So we will have x times x minus 1 equals 0. So there are two intersections, that is x equals to 1 or x equals to 0. So then we want to substitute the x value back to get the y value. So the two intersection, if x equals to 1, y also equals to 1, x equals to 0, y also equals to 0. So we have found these two intersections here. Well, because of the time, let's do this together. So first thing first, let's transform them all into this standard form. And now, since we want to find the intersections, at intersections, they have the same y value and the x value. So we could let these two equations equal to each other. Well, by looking at it, I don't feel like I could do factorization easily. And I don't like completing the squares. So let's using this magic formula. First of all, checking the discriminant greater than 0, so we could proceed. x equals to negative b. What is the value of b here? Negative 7, right? Plus or minus square root of this discriminant over 2a. Sorry, x1 equals to 4.31. x2 equals to negative 0.81. And comparing this graph, we found, yes, indeed, they intersect at these 2 points. You could substitute this x value back into this other formula here, other equation here. So we have finished all the topics that you should know for quadratic equations so far. And it's time to see some application of them in real life. So here's a question I made up. Imagine you are sitting under an extremely tall tree, a 10-meter tall tree, and there's a monkey on top of this tree here, and it's throwing a banana towards you. You are sitting there, and the banana just falling on top of your head. The initial velocity of this banana is negative 5 meters. So the question is, how long does the banana take to hit you? If you are ready, let's bring this back together. This is quite a long question, but it's just asking what is the value of t when the height equals to 0? T represents the time. H equals to 0. So when this formula equals to 0, what is the t value? So again, you just have to solve this equation here. So I just want to rearrange this into its standard form. And then which method you want to use to solve it? Perhaps, I don't know, perhaps using that quadratic formula. Because we have this 4.9 here, it should be very difficult for us to complete the square. Okay, so I have done all the calculation here. You could compare it with your own solutions. So since d, the discriminant, is greater than 0, we have two roots of this quadratic equation. T represents the time. Could time ever be negative? No, right? So we will say something like t cannot be negative. Neglect the roots, active 1 equals to negative 2. The final result that is that it takes 1.007 seconds blah, 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 to hit you. Another question here. So you have a photo here, this one photo of a people. The photo is 12 centimeters tall and 16 meters wide. You want to add a frame to this photo, this yellow frame outside here, and you want this total area, the photo plus the frame, to be 252 square centimeters. So what should be the width of this frame be? The width, which is labeled x here. What should be the x here? Pause the video and try it on your own. You may find that the new width of this photo frame is 16 plus 2x. The height is 12 plus 2x because we have one extra x on each side and one extra x on top and one extra x top or down. So this is the new area of this photoist frame. This is new height. Okay, so this is again a question to solve quadratic equation. Well, first of all, I could factor out this common factor, which is 2 on both terms. So this equals 2. So I can divide by 4 on both sides. So the first one equals to x plus 8 times 6 plus x equals to 63. Expand this and we get 14x plus 48 equals 63, and write it into its standard form. What is 48 minus 63? That is negative 15. Okay, nice. In this case, I feel like we could do some factorization because 1 times 15 and also 15 minus 1 equals to 14, right? Okay, let's see. 14 minus 1 equals to 14. But if I have negative 14 plus 1 equals to negative 14, this is not what we want, and we want this. So I will use this negative sign in front of this negative 1. So x, and cross product. So we have x plus 15 times x minus 1 equals to 0. That means x1 equals to negative 15, x2 equals to 1. Again, we should say something that x is the width. It could not be negative. Can't be negative, so we will only keep this root, which is x equals to 1, so width is 1. Okay. This is the last question here. This is a simultaneous equation. We again want to find the intersection between these two roads. One curved road represented by this quadratic equation and a straight road represented by this linear equation. So we want to say how many intersections are there and where are they? So I have built this simultaneous equation. Luckily, we don't need to do any manipulation on it because they are already in their standard form. So we just equate both sides. And try to solve it. Could we do factorization? Let's try it. If I multiply 2 by both sides, we multiply negative 2 both sides. Okay, it doesn't feel like I can do factorization. Complete the square, just for fun. So what is the value of b here? The 2ab here is negative 6x. 2b equals negative 6, so b equals to negative 3. Okay, so we have x squared negative 6x, and we want b squared, that is negative 3 squared, and we don't change anything on this constant 3. And since we add a b squared on the left hand side, we also need 1 on the right hand side. Change this part into x plus b squared, which is x minus 3 squared plus 3 equals to 9. X minus 3 squared equals to 6. And then x1 could equals to square root of 6 plus 3. X2 equals to, well, negative 6 plus 3. And this is the final result. I believe it looks some kind of similar with this graph. So this is the final slide of this topic. If you revisit these learning outcomes, I hope they don't seem to be overwhelming anymore. And if you have any questions, or if I made anything confusing, I'm welcome for any questions. Thank you for listening.